After completing this lesson, you will be able to understand structural framing, understand structural usage, and create concrete and steel beams. The objective domains covered are 1.1e, work with structural framing and connections. Beams are load-bearing structural elements that form an important part of structural framing systems. They must primarily resist bending and axial loads, and are often connected to columns and walls to transfer the loads to other structural elements. Beams can be formed from a variety of materials such as in situ concrete, precast concrete, steel, or timber. The type of material used has an important effect on how elements are joined to other elements. This property is called the model behaviour, and it is set in the Revit family parameters. In the example shown, a concrete frame will join and become monolithic, but other concrete members such as precast, steel or timber will have a gap between the elements. The structural usage of a beam determines its rank, a girder being a primary member, a joist being a secondary member, and a purlin being a tertiary member. Revit automatically detects the structural usage based on what the beam is connected with. If no connection exists on one or both ends, then Revit will set the usage to other. However, structural usage can be overridden if required. Go ahead and open up the file 010, work with structural framing. The model will open up in the first floor plan. Our first task is to draw some girders in the front section of the model. On the structure ribbon, let's select beam. On the context ribbon, you'll note that we have the ability to load a new family. We have our draw panel displayed with various different drafting tools. We can place our beams on grids and also tag those beams as we place them. On the options bar, the placement plane is the level that the beams will be sitting on. By default, this will match the floor plan. So in this case, we're on level 01, first floor. But you can see here that we can override and change that if we require. The structural usage is set to automatic, so Revit would auto detect the structural usage of the framing based on what I model the beams between. However, I could override this if required. You'll also notice here that I have the chain option switched on. In the Properties palette, in the Type selector, go ahead and select W16 by 26. As I model my beam, you'll note that I'm going to snap from the column midpoint to the column endpoint here. Before I go too much further, let's open up the 3D view and have a look at how this beam has been modelled. You'll note here that although I snapped from column centre to column centre, the beam is in fact cut back to the columns. The analytical model will still remain connected to those column centres, but the physical size of the beam will cut back to the bounding box of the column. This is due to the material usage of our beam. Okay, let's switch back to the first floor plan. We'll now continue to draw some more girders. Here, I'm going to select the original girder I've just drawn, and up on the context ribbon, I'm going to click Create Similar. We can now draw our second girder. I would now like to create the rolled beam around the front of the structure. To do this, I can select the start end radius arc, and then go ahead and snap to the column endpoint, the column endpoint here, and finally the endpoint on this raking column here. Again, if we look in 3D, we can now see our beams are modelled. Next, we're going to model an in situ beam across this part of the structure to give the floor slab a little bit of extra support. So let's return back to the first floor plan. On the structure ribbon, let's select beam. In the Properties palette, we're now going to ensure that we have concrete rectangular beam 12 inch by 24 inch selected. We can now draw our concrete beam between the column midpoints. Notice that the difference here is this in situ beam will join and become monolithic to the column. Next, we investigate the difference between a girder, a joist, and a purlin. To do this, on the Structure ribbon, let's select the Beam command. In the Properties palette, click the Type selector. We're going to change our section to W12 by 26. Now, when I model the frame in here, this slab is slightly lower because it's a steel deck. So what I can do here is change my placement plane, and you'll notice here I already have a reference plane set up called 01 top of steel. Even though I'm on the first floor plan, when I create this structural framing, it will now be constrained to that reference plane. So now I'm going to model my girders. If I select one of the girders that I just created here, in the Properties palette, you'll note that the structural usage is set to girder. We're now going to create some joists across this framing system. So once again, we can select our beam. We'll select Create Similar. Now, just for this example here, I'm going to create a joist in between the two primary beams. And I'll create a second one through here. If I select this member, you'll now note that the structural usage is set to joist. If I now create another beam, this time I'm going to span between the two joists, and we then go ahead and select that member, you can now see the structural usage is set to a purlin. If I create another beam and I just model this without connecting it to any other elements, and I select that beam, you'll notice the structural usage is set to other. Here, of course, we can change that though. I could go back and say, actually, it's a girder. The significance of this is it can determine how the structural framing looks in a coarse level of detail. If I temporarily switch to coarse level of detail, and I toggle on thick lines, you can now see clearly we have different thicknesses for our structural framing. Now this can be set up in the object styles and you don't have to accept this style, but you can see each of the different structural usages will display differently with this particular template. Now of course, if I don't want that to happen, I could simply override. So here I could set this to a joist and you can see the appearance now changes.